of July this year.
Sound.
The challenges, there are 4 main challenges: feed the fish, up the garden path, tidy up the toys, and obstacle course. I'll say a bit more about those later. Then different points available for the different challenges depending on how you did them, whether you just used wireless remote control, voice commands, autonomous, or vision using the Pi camera. There were also points available for blogging during your development and for a video on artistic and technical merit. There was a separate Pi Noon knockout competition, which is the robots bursting balloons on each other, and those were operated across the internet as a knockout challenge. There were 2 days of competition. First day is for young teams and schools, and there were 20 entries from England, Scotland, Ireland, Puerto Rico, India, Australia, and the USA, which was pretty impressive. Day 2 is individuals and older teams, basically non-school stuff, and 26 entries there from England, Canada, Italy, Peru, Sweden, and the USA. You had to build your own arena to do the challenges in. It's 1.5 meters square with small walls all the way around. Didn't matter what color it was going to be or what material you used. And here we're just showing it set out for 3 of the different challenges. Feed the fish, where you have to push or launch some balls from behind one area into a receptacle on the right-hand side. Up the garden path, which is basically a line-following course, but with branches in it, and you had to take the right branch. And then tidy up the toys, which was to collect 3 different coloured blocks and to put them in sequence over in one corner of the course. The contestants had to record and submit a video for each challenge, plus an extra video for artistic and technical merit. And I didn't mention, there's the obstacle course where you could set your own course up, a video, and submit that as well. I've included a link here that takes you to all of the submitted videos and blogs. And it's worth having a browse through some of those to get a better idea of the range of solutions and challenges and the standards of the robots. Now let's have a look at some extracts of some of the videos.
Tidy up the toys. Autonomous, with the blocks stacked side by side.
We're a little bit out of sync on the sound, but don't worry about it.
Hi, my name is Cormac Sheridan, and we are doing the DIY obstacle course, take 1.
And 3, 2, 1, hit it.
Now you've seen some of the videos, and I think you'll admit they're pretty good. Just want to say a little bit about how we did at Cow School. Had a number of last-minute hiccups. Probably the worst one was the fact that our Pi motor hat, which although it's got a 30-volt regulator on it, didn't like us putting a 3-cell LiPo on it. And we managed to blow up 2 Raspberry Pi 4Bs in the couple of weeks before the competition. So that was bad news. Then the school decided to have an extra inset day after half term, so we lost 3 weeks of clubs there. Because of the lack of time in the last month or so, we ended up having to do the challenges under remote control rather than quite a few of them which we were hoping to do autonomously, which would have given us a lot more points. Anyway, overall results for schools, basically there were 2 categories, novices and experienced. We were actually down as experienced because we'd done PiWars before, but if we combine all of those, then on the points we came out at 9th, which is not too bad, about halfway through. On the results for day 2, the non-school stuff, again, I've just combined the beginners, intermediate and advanced scores here all together. And it's interesting to see that actually some of the schools scored more points than some of the non-schools, older competitors. But a good range of scores and a different level of achievement from the different teams. So, concluding, it was nice to have a good variety of different challenges. You could tackle the challenges at different levels of skill, you know, remote control, autonomous, vision, speech control, whatever. Running the challenges at home meant that competitors from around the world or teams that couldn't get to Cambridge could compete, which meant it opened it up to a lot more people. Teams had fun making the videos as well. It's just another skill for them. In terms of the issues, it was difficult to keep all the school team actively working on one robot. We had 6 people in the team, and once we were onto the programming, it was difficult for more than 2 of them to be working on that. So, whilst we enjoyed the PiWars challenge, I think we'll go back to UKMARSBOT again next academic year, because that way we can get everybody having a robot to build and to program. Okay, that's all from me. Hope you enjoyed it. Any questions from anyone?
Yeah, was the garden path one autonomous or just remote controlled?
The one that was like the line follower?
Yeah.
Basically, you could either do autonomous, remote control, or speech controlled. And with speech controlled, you had to have at least 4 different commands. So you could do start, stop, go left a bit, go right a bit. And you use that mainly. Most of them, or quite a lot of them, did autonomous with just sensing the line, plus some sort of either remote control or voice control for deciding which way to go at the junctions.
So right, with voice control, so they'd get to the junction and then say which way to go.
Yeah.
Yeah, that's good.
I mean, we actually got that just about working before we had all the problems, which was the nuisance. So we ended up doing it on remote control instead, which was not as good.
Were the videos your ones or others?
The one of the Up the Garden Path was our video, but all the other ones were just a selection of some of the other ones. The obstacle course one, I thought that was the best video as such out of the lot. I mean, it was just a really good fun one. You got points for fun as well as for competing it and under what type of challenge you did it.
Right. Well, that's good. Which one? The one with the blocks, the toys.
Oh, yeah.
Yeah. Was that doing anything in that particular video? Was that doing it autonomously, or it was very difficult to tell whether it was just doing a fixed pattern?
No,
I mean, it was doing it very reliably, but
I'm pretty sure that one was doing it remote controlled. So just a wireless gamepad on that one. But we had some that were doing it with cameras and actually doing it. And also we had some that when they got to the blocks, they actually stacked them one on top of each other.
Right.
So they grabbed one and then pushed it up, and then grabbed another one and pushed it up, and then took all three of them round at the same time down to the place where you had to deposit them at the end.
Okay. Well, whoever was controlling that one was doing it very well.
Yeah.
Ridiculously consistent.
And also the feed the fish one, you had a choice. You could either push balls into the bottom part of the container, or you could fire balls or darts or anything of a certain size or above into the top of the container, and you got more points for firing them into the top of the container. And you were allowed 3 goes of up to 5 projectiles to send them in. With ours, we actually had like a trebuchet that held 5 balls, and we just drove up and then fired all 5 in, of which 3 went in and 2 missed on each time. But we got 9 out of the 15 in.
Yeah, sounds good.
Great. Anybody else for David?
But I say it's certainly worth having a look if you're interested in any of that. Just have a look at the link that I've provided there, because that takes you to all of the videos for everybody. So there's 150 videos or something there of all the different challenges and all the different ways they did them.
What's the reaction of the school to changing between PiWars and then the more conventional MicroMouse stuff?
It's pretty much down to whatever I want to do. They don't have any particular views on it. They're just really pleased that somebody is happy to come in and help to run some extra curricular activities.
Sure.
Basically, I say that when we've done PiWars, and this is the second time we've done it, you get 1 or 2 of the lads into the programming, and they sort of, get on top of that. But once they're doing that, it's really difficult to get the others doing anything, and you end up with 3 or 4 of them just sort of spending most of the club time just playing games or Minecraft or looking at their phones or something instead. So that's another reason why I prefer to go back to the UKMARSBot, and everybody's got a robot to build and to tune and to program.
Right. Thanks. Well, thanks, David. Thanks for recording it. I don't know how we were getting sound to you. I have a nasty suspicion that it was just bridging through my speakers into my microphone and back onto you guys. But there we go.
It came through okay.
Rob, hi.
Hello, can you hear me?
Yeah, we can hear you perfectly.
Good.
And Rob's going to give us a session on the PiZero on the UKMARSBot. Is what I'm hoping he's going to do. Anyway, that's what I think he's going to do. So I kind of hand it over to you, Rob.
Yeah, sure. So I'm going to stop my video and share my screen. So can anybody read that font?
Yeah.
Read that one.
Okay, so this is a bit of an update, I think. I can't remember whether I spoke last of this, and a good number of months ago anyway. So I've done a couple of things. One is talk about what I've played with the hardware, because, of course, you can't leave hardware alone. So originally I was running a PiZero on this, and all the instructions on the GitHub page are for the PiZero. I swapped to a W, the wireless version of this. And you can see, I've got some more photos, but you can see I've effectively put a bit of strip board on the connector, on the PiZero connector, and run power to that. I also have added a buzzer. Now, one of the advantages, I was running the PiZero off the 4-way connector, the serial connector, including the power. It was okay, but I had occasional, I didn't have any power outages, but I had occasional serial problems. This appears to be a bit more stable. I also put a 3-volt 3 buck regulator underneath. it's lost me a couple of millimeters of clearance. Currently, I haven't got the bottom board lowered as much as I could do, but I have got a few millimeters I could take it down. So that's sort of what I've done on the hardware. That seems to run okay. What I wanted to do was talk a bit about. Let me talk about the Nano. So I don't know the last time me and Pete had worked on sort of UKMARS, which is the Nano software, the command software. And after that, I think Pete came to controller. The original controller wasn't as good as he liked. So he swapped to this sort of incremental control that he spoke about last time. And I've ported that onto the UKMARS now. So that's the same controller, speed rotation controller that is running on UKMARS, the Urinal UK, the Maze Runner. So all that's been ported across. I've decided to put or try the steering adjustment, which is sort of keeping it in the middle of the cell based on the left and right sensors on the Pi. As you'll all remember from Pete's code, he obviously does that in the Nano along with maze solving. I'm sort of interested whether I'll have enough, whether it'll be good enough. I think it will based on some basic tests, but the jury's out. It's relatively easy to swap it back to the Nano if we want. I was running 115k. So as far as barring me finding bugs, the sort of Nano command software is working. Operates in a couple of modes. You can put it into sort of verbose and an echo mode if you're running it from a terminal window. The Pi software turns off the echo in order to save a few bytes of bandwidth. It's actually got two modes. It can actually listen for the OKs to validate all commands, or these three sorts of verbose modes, and it can knock those down. It's got some options in the PiZero software. I thought I'd mention what I've been doing on the debugger. So originally, when me and Pete were working on UKMARS, the Nano software, although I was running it from the PiZero occasionally, most of the time I was running it from a PC or a Mac over either a USB or a Bluetooth module. I'm running the Python software straight off the Mac, running it as a sort of remote control robot. Over the last few weeks, I've actually been running it from the Pi. Now, because I swapped over to a PiZero, I had a couple of options. PiZero-W. I had a couple of options. One was to run over the Wi-Fi, which is what I do on one of the other robots I've got. The other one is theoretically you can also set the Bluetooth up as either a client or a host. I started on that, but I never got round to finishing it. So currently it's running all over on Wi-Fi. And I'll talk a bit about that, what I actually do when I'm developing in a second. When it's standing still, it's still running off a nickel metal hydride battery, 9-volt battery, for both the PiZero W and the Nano and the motors. Obviously, if you're doing some standing still debugging for a few hours, then it gets through nickel metal hydride batteries. So I've got a 4-amp PSU I used with one of the other robots when I was doing sort of stationary testing, connected a PP3 connector to that. Put SSH keys on the PiZero so you could just log in. Added an extra library, the GPIO 0 for the buzzer. I added a buzzer onto the hardware just because I could. Not mandatory, just a bit of it. It's a self-oscillating buzzer, so just a bit of beeping when I want to hear it when it's moving. I've got I can probably actually show you this, but I've got two terminal windows open most of the time. I use an rsync command that I put in this presentation notes just to sync it. So that previous time on Vision 2, I actually had a Git client on the PiZero. I'm not doing that here. I just run rsync and it synchronizes it from my laptop. And then generally I've got an SSH connection running all the time. And then I'll for instance, to give you an example, I might run, for instance, the buzzer test. And there's a few test programs. Most of the ones at the moment I'm running. My original plan for this was to, as you can see, for these, I started on print data sensor test, which does the IR sensors. Then I had one to do a circle pattern. It runs straightforward, does a circle, runs and finishes that circle. And I plan to have a bunch of extra Python files to do various things. Because Pete's done Maze Runner, my current stuff sort of swapped off to sort of port the high level stuff over to a Python file. So that's the maze solver that I'm sort of in the progress of at the moment. So this is oops. So yeah, SSH is robot. It's called Python 3. When I actually run this on the robot for real, I'll get it launched the Python script from RC local. I'll probably actually run it under screen. So screen and tmux for anybody that hasn't used Linux or Unix, a sort of a virtual terminal. Now, the advantages are that it captures the standard out, which means that you can effectively, even if you disconnect from your terminal session, you can connect to that screen session and see what it's been printed out. On previous robots, I've written to a log file, which you can do, but it's a bit more work. Also, I've been running Minicom. Obviously, I can plug a USB cable or straight into the Nano and sort of fiddle directly with the command language. But you can also just run Minicom, a serial terminal on the. So this terminal window, which you probably can't see, it's the font's too small. I'll zoom it up a bit. You can run Minicom on here. And this is actually that's the Nano talking to the Pi. If you want to do, various like sensor tests or whatever to find out what the sensor's doing. I guess maybe before I go on to the next slide, I know I covered a bunch of stuff about debugging. Obviously, you get copies of these slides. If anybody's doing anything on the Pi, I guess people are doing sort of similar things, but I thought I'd cover how I was sort of debugging it. Obviously, if it's doing complicated movement, then you're sort of stuck to printf and the like, and maybe log files on the Python. I have got a mode where it will log all the commands it will send down to the Arduino, and it doesn't save that while it's running. It saves that at the end of the run. Before I go on to the sort of Python software, has anybody got any questions about the debugging on the Pi?
Okay. So are you running? You said you were running some of it, or at one point, just as a remote thing directly from the Mac. Is that the Mac running? So that's the Mac running the Python software.
Yeah, I mean you can
directly.
Yeah, exactly. So I mean, I'm gonna lead here, but you could effectively go into. If I just go into the.
Perhaps it would be worth reminding folk that the actual connection to the Nano is via its serial port, which could be a Bluetooth or physical connection. And so because all of the commands are just text sent over the serial port, it doesn't really matter how you get there. So you could be sitting on a PC somewhere, connecting via Bluetooth and a serial adapter and talk to the Nano and tell it what to do. Or you could have the PiZero or anything else for that matter poked on top of the robot and connected via the serial port, and the effect is the same.
Exactly. It's quite interesting actually, because I was prior to this, I was basically running all of these Python scripts on the Mac, and I've actually got some abstraction in the code. It's probably going to be a bit small maybe, but if I go into Python, there is a robot libs and some general. He says, looking manically for the file is. So these there's a set of commands that you can run that are so you can just call a Python function to read a GPIO input. You don't actually need to remember what the commands are. But there's also a there's also a file that that abstracts the interface. So which obviously I can't remember. Oh, here it is. Right. So this robot settings, one of the things it does is, so I don't even need to effectively switch the serial ports, because when it boots, it detects whether it's running on a Raspberry Pi or on a Mac or on Windows. Now, obviously, you might need to switch the serial port depending on what you're running on. So if I plug like one of those HC05 dongles into the Arduino, into the header on the UKMARSBot, you can just run this and it'll do the right thing as long as this serial definition's correct. Then it'll run the host program, if you like, from the Mac, or you can run it from this is on the Raspberry Pi, or you can run it from here. You can use it as a remote control robot, which is sort of interesting. I know, Pete, I think you're interested in that as well.
Mm. Of course, this go.
A very simple remote control that just sends some, individual characters move left, right, forward. That could be a two-part thing, or it could just be a wire connection, or there's lots of possibilities. Once you've separated out the UKMARSBot and what it physically does and who tells it what to do, how you link them together, there's lots and lots of possibilities.
Yeah, and this of course brings up a question about whether we should allow a remotely controlled mouse, from something else. It would also mean that you could put a Pi at the side of the maze, and you wouldn't have to power it on the thing. You wouldn't have all the problems of powering the Pi. It could just remotely run it, which I think would be perfectly good thing to do.
I think it would be very entertaining if somebody could if we had like a camera feed for the contest, right? And if somebody could tap into that and use that to control the robot, I'd be well impressed.
Yeah, of course it does. You could put a camera at the top and control it, and that would be impressive.
I was also thinking just now, when you were talking about moving the steering control onto the Pi, what if the PiZero will run a Pi camera, will it not?
Yeah.
Yeah. So suppose the PiZero did some image processing, and at the moment in the Maze Runner code, the sensors calculate the cross-track error, right? The deviation from center line. So suppose the Pi could use the camera either for line following or for in the maze, and generate the cross-track error and then send that to the MarsBot. Yeah.
So I had it wasn't a UKMARSBot, but I had Duncan probably remembers it, rather shortened. I got a PiGo Pi, which is quite a big robot with a Raspberry Pi on, and that was detecting the line position for line following. I'd also got code that run on my original Vision robot that actually runs on the Pi that looks at the maze, and in fact so I've actually got code that potentially that I could port across to the UKMARSBot maybe to do some of that, given enough time and enough hours in the day.
The problem is it's always going to be slow if you use a camera, because you only got 50 hertz frame rates or something.
Yeah.
So you're only going to find out where you are every 20 milliseconds, even if all your video processing is incredibly quick, which it probably won't be.
This is very true, but you can also see further ahead.
Yeah, you don't need that sort of rate of processing. If you can see further ahead, because you can make predictions between the where it is and where it thinks it's going to be. So it only needs to be able to work out that it's not pointing in the right direction quickly enough to avoid the wall.
Yeah,
and you could also generate on the camera, the optical visual processing camera, whatever you want to call it, on that box, you can generate a trajectory that is followed virtually. So you're not really doing this kind of frame by frame or instant by instant control. You're creating a virtual trajectory for the robot to follow.
Yeah, I mean, in my opinion, the problem isn't, and obviously on the you can always leave the IR sensors on to do some processing as well. But the problem from my point of view for anybody doing camera stuff is the giant mountain you need to climb up to do the simple stuff at the top, right? So I mean, maybe if we get a bit further on to having like a Pi on a maze solver, then we've got some people working on maybe some basic libraries, then maybe it makes it much more accessible. I don't think in my, although I mean there's a lot of pixels to process on any image, but you can actually do quite a lot very simple stuff. But it's the fact that you've got to assemble the whole thing and then get all the software working, which makes anybody who's doing line following or maze solving with a camera, it increases the amount of effort they've got to spend. I would like to think, but maybe doubles the amount of effort they've got to spend, perhaps.
It is all running before you can walk. I agree.
But in principle, I think that maybe it does help. Anyway, we'll see. One thing at a time. So my plan. Let's talk about what I've got. So I think I've talked about this. I've shown you some of the libraries and stuff. So I've got a sort of commands file that all those sort of command strings that you can see on here on this UKMARS front page on GitHub. So you don't on the Python software, you don't need to issue all of these commands. You can just sort of ask it for a set of sensor readings. So that commands file abstracts that away. And sort of now the thing I'm doing is sort of porting or re-implementing in Python the sort of maze solver from Maze Runner. Currently, I'm actually playing about with some sort of background monitor task. So, you want to be able to tell it, you want it to take care of sort of the low-level control and the steering while you're waiting for it to do sort of a mid-level control thing. That's what I was playing about with over the last sort of week. And those are the links. So I think, what we really want is for it to do what we did with Maze Runner, which is, have a sort of skeletal maze solver on the Pi, which is not quite there yet. But I don't think it's all the low level stuff's done. And go ahead, Pete.
We say quite often when people ask us at competitions about building the robots and doing this, that, and the other, one of the constant things is about the difficulty of solving the maze, and almost universally our response is it's the last thing you want to worry about because it's almost the easiest. And that'll be the case here as well. Once there is reliable communication, good feedback from the robot, and adequate control, making it do what you want to do at a high level is a relatively straightforward thing, I would hope. I haven't looked at it for a little while, I confess. I've been playing with other things. But when we were both looking at the UKMARS software, one of the things which I don't think, and I don't know if Rob agrees, but I don't think we really kind of bottomed out is exactly where the boundary should be between what the nano on the MarsBot is responsible for, definitely, and what the Pi host is responsible for. Clearly, generating the motor speeds and things like that, and actually reading the sensors is not something the host can do. The nano has to do that. But somewhere in between there and the high-level control of move forward 20 centimeters, turn right, or perform an arc at 16 degrees per second or whatever it might be, somewhere between those is a boundary which I don't think we've really, kind of clearly defined. So if anybody has the time to have a look at this and have a think about it, I'm sure we would be appreciative of any suggestions as to where things are placed.
Agreed. Even just reading through the command list. So it sort of grew organically, and there's some very low-level commands about, reading and writing I/O, which was useful when I just soldered a buzzer on. But there's also that sort of high-level sort of different sensor reading, and there's a question about, what I suspect different people are going to tackle this differently. That's going to be my impression. That different people are going to have different opinions, and how much it's not just what level of control you put on, in terms of high level or low level control, but it's also the general approach. It's easy once you started to go down your own path to think that's the only approach.
Mm-hmm. And presumably a lot of it is dictated by the link speed. So as you say, you can't send 1,000 commands a second to it to do something like check the sensors and do things. So anything that's got to be done repetitively at sort of millisecond type levels is going to have to be done on the nano. While the other one's going to be doing, all the high level solve, get the sensors once a cell and solve the maze and that sort of stuff.
Yeah. I mean, I haven't measured on a real, apart from doing, we measured some of the timing for commands. So, for instance, we print some of the stuff we print, like the battery voltage. You can get it to print it as a decimal, like 8.9 volts, 8.9. As a floating point, and there is some time taken to do that conversion. But I think what we were seeing is that even those conversions were being, we were sort of almost beating it was sub a millisecond to output that command. So, I mean, there is a question about, me and Pete had a brief conversation about whether these commands should be as terse. So most of them are sort of single, double letter or, full characters. 115K, you're talking about, if you're turning off the echo, then, well, I guess you got 10 kilobytes per second in both directions, theoretically. The Arduino won't keep up with I think it's going to top out somewhere between 1,000 and 2,000 commands, maybe. Whether you actually get that right in a real connection is a different matter.
Especially a wireless connection.
That introduces a whole different ball game if you're talking about Bluetooth or BLE, right? But even on a serial connection, our conversation was it was unlikely we were going to be able to do. I mean, on a different plane, if you had a higher speed link, you might have even decided to do the speed and the rotational control on the host as opposed to on the the sort of on the Nano.
It would wreck your control loop, unfortunately. But the delays would wreak havoc with your control loop.
You need something predictable, don't you, for the delays,
real time. But also,
so I think
isn't it 115 kilobaud? You can process, you can send without too much grief, maybe 100 commands a second. You know, if you up to 20 or 30 bytes in a line, you can actually get a surprising throughput.
Yeah.
Mm-hmm. But is that the same while the thing's going along at 3 meters per second with all the interrupts coming in for the wheel counters?
Yes, I think so. The maximum load that I recorded, I think, was about. It's got a 500 hertz control cycle on it, in the Maze Runner software, and obviously the amount of load taken up by the encoders depends on how fast you're going and what the resolution is. But I think I got it about 40% or thereabouts. Yeah. So there's surprising amount of steam left in it, I think.
Yeah, for a poor Mega 328, I'm actually surprised. Compared with, if you swap it for almost any other micro nowadays, you gain almost a order of magnitude processing power.
Yeah, but it's optimization. I've done nothing. There's floating point where I wanted floating point and stuff like
lots of floating points. Yeah. So I think what I will do, Derek, at some point when it's running properly, as opposed to just sending a couple of commands to do some basic stuff. But when it's running properly, what I'll do is I'll actually put some. Well, I'll run a capture with timestamps, and we'll get an idea of how many actual commands it's running on when it's actually doing real maze solving, for instance. I think that'd be much more. We'll get a much better idea of the realistic sort of throughput of commands. Because I certainly could run 1,000 commands a second on it, but it's not very realistic depending on what the command is. A lot of the time we're going to be waiting for either sensors to change or I suspect there'll be a bunch of polling, and there is actually mechanisms so you don't need to poll. It can return unsolicited messages, but I suspect at the moment it's going to be polling for either when the controller's finished or when the sensors are changed state. And we'll probably read the sensors during the idle loop, sort of back to back when we're not doing anything.
I think if you could get a high level control kind of loop rate of 50 to 100 frames a second, I think that would be quite respectable for what it is.
Yeah. Okay. Any other questions?
So, hi, Rob. When I said I worked out a system load just for entertainment, the way I did that is to take downstairs. It's 100 microamp analog meter, a suitable resistor to limit the current, connected up to an I/O pin, and every time you're in an interrupt, turn on the I/O pin or the output pin, and every time you leave it, turn it off, so you get this kind of asynchronous, arbitrary series of pulses coming out, and the meter averages the current for you from 0 to 100, and you get a direct reading of percentage system load. It's kind of entertaining to watch, really. You tell it to do stuff, and the meter moves back and forth, and you don't have to do any sums or anything. It just tells you.
Or you could just connect it to your scope.
Bit big, really. The meter I got's quite tiny. Don't know where it is.
All right, you've got it going while it's running round.
Nice, an old VU meter or something. I don't know.
Yeah.
No sound.
It's interesting, Rob. I was looking at that because I haven't done anything with my Pi that's loaded up on top of the UKMARSBot, but I had been thinking about approaching it top down, almost starting with really simple stuff like the Pi just says, do a rule follower, do a maze solver. And then you can incrementally come down to the levels of granularity and you can decide what you want. But I'm actually almost persuaded at the moment that the Pi might add more value if it can actually look ahead. And if it can actually look ahead more cells than the IR sensors, then you may actually be able to save yourself some time that way. But they're very vague thoughts at the moment. So whether it's just, David, I guess the question for the Pi people is that they have to demonstrate that the Pi is essentially controlling the robot, and I'm not quite sure how much it has to do to qualify for that.
Yeah, I mean, basically, as long as the top level control is being done by the Pi, then they don't mind if you're using some Arduinos or Nanos or anything else sort of to do some low level stuff.
All right.
I mean, they're not too fussy about this stuff or too pedantic about it. Nobody's there with a scrutineering team checking stuff or looking at your code or anything.
So you could just say, go do a maze solving Arduino. Tell me when you've finished.
Yeah.
I guess if it fails to work when you unplug the Pi, then the Pi was in charge.
Yes.
You sound like a politician, Pete. That was the old approach to power loss testing, wasn't it? What happens if I pull this plug out? Rob, thanks ever so much for doing that. I know you were kind of up against the clock tonight coming in, so thanks for picking it up. I guess it's open session now. Anybody got anything else they want to talk about?
I've got a quick suggestion. With in the last meeting, we were talking about some problems with the motor driver on the UKMARSBot.
What problem?
Remember that? Some people blew some up and found it very, very difficult to change.
Oh, yeah.
Yeah, I blew one up, yeah.
Yep. Okay. So I just thought I'd show what I've got on the PIC 1 for that, because it seems to be quite a good, quite a good system, and it might be worth, looking at. Might not. Might be too difficult to implement. But I use a TC4423, which is actually a MOSFET driver chip, and two of those. And the advantage with those is that there are a lot of companies that make them. Probably every analog silicon manufacturer make a version of that chip. They've been made for years. They're probably going to be manufactured for more years. So you're not reliant on one particular vendor doing a single chip, which is what that module is. I think it's a Toshiba chip, isn't it? I mean, it may already be discontinued because they tend to pull them out for ages.
What, the TC or the 88, whatever it is that we've got in there?
The both. I mean, I just gave you obviously the one I use.
Oh well, the TC4423 is actually a microchip part, I believe.
Yes, it is. Yeah, that is a microchip part. But they have a lot of other numbers under other, making the same chip. So it's the same So, well, in fact, they have a lot of different specs, which is another advantage of them, is that you can get very cheap ones that probably have quite high. One of the disadvantages it probably has a higher on resistance than something like the Toshiba one. But the big advantage is it's available in through hole. If it blows up, you can pull it out, socket, and stick another one in. And that's just what we've been doing. So we've been running those since the very first PIC ones back in 2009, something like that. These chips, because they're made by multiple companies, are likely to be made for a very long time. So you won't suddenly get, Toshiba end of lining it, that sort of thing. What's the other advantage? Another advantage is that you don't actually need the XOR gate that you've got under the thing. It runs without that, so you could probably get rid of it. The disadvantages, of course, are that it's going to, mean redoing the PCB, which you may or may not want to do. But I just thought I'd put it forward as a solution to that particular problem.
There were several reasons for picking that motor driver, and I think one was that you can just get it all slung together as a single module. If there was room to socket it, they would have socketed it.
It's not socketed because of the USB connector, right? On the Arduino.
Which is, and after n million iterations, overall a better solution would be to find a way to put it in a socket without being in the damn way. And I think, can't remember why. Oh yeah, I know. The reason why the Nano's not the other way round, right? So that pokes out the side, is so that we can accommodate larger wheels. Now, if you don't need to accommodate larger wheels, the Nano can be flipped around and have the USB connection on the outside, and then you don't have a height problem, and then there's room to socket the motor driver, right? But if the USB connectors are so big that the only way we could accommodate a proper bigger wheels was to put the Nano where it is, unless you use the hen's tooth connector, which is a vertical right angle USB connector, which you can get, right? But they're much harder to find. So that was a thing, unfortunately. The 4423 and its cousins have a bit of a constraint. They've got their RDS on is several ohms, maybe 5 ohms, and so if you try and they will automatically current limit, right? So by the time you got half an amp going through, you've already lost 2.5 volts from the motor.
Yeah, driver. I mean they're different, and most of the different ones, you tend to find that they get more expensive, and you can get lower RD-ons on them. But yes, that's one of the disadvantages, is that that's higher. But things like PIC 1 Turbo is using those, and certainly would appear to go fast enough.
Yeah. And one of the other options is to go really basic and put longer pins on your Arduino and just stick it up a bit more, and then you can socket the motor controller and still clear the USB port.
Just put another socket in the socket,
or just use
it on the top.
Or just use a long
Just
length.
not blow them up, for goodness sake, people, get a grip.
Well,
Presumably the bigger wheels they're only for the drag race. Is that right? You're not talking about...
I haven't seen them used yet. I don't think anyone built one.
They were a design request.
Yeah, the plan was that we could then use bigger wheels for the drag race, or possibly even for the line following.
Right, but you can use you can get those gearboxes down to 5-to-1, which is which is much quicker, rather than putting bigger wheels on it. You could
right, but the idea was that we wanted to be able to just use the same robot and just swap the wheels over.
Right.
So you had the small wheels on for...
They will climb larger steps. because the PiWars type contests.
Correct. Correct. The reason they blow, by the way, Peter, is that the Pololo motors have a horrible habit of failing short circuit, and the controller doesn't protect itself in time.
Right. I wasn't trying to cast aspersions, clearly.
I mean, these chips are just little tiny 8-pin chips. So they're standard through-hole 8-pin chips. You could put 2 of them easily in the space that you've currently got the board.
Right. Is that what you put on the PIC one, original PIC one?
Yep.
Yeah.
That's right, yeah.
Yeah.
And they don't need anything else. I mean, a capacitor across them, I think, is asked for.
As it turns out, again, almost anything made of silicon that's not sand off the beach is like a nightmare at the moment. So.
Yeah.
Just trying to find one of the boards. Oh, there we go.
Yeah.
Can't for the life of me remember what it is. I can't find the right doctor.
I think it's a Toshiba chip.
Yeah, it is. The one we put on is a Toshiba TN, I can't remember, 866 or something, but it is a Toshiba chip. But it does have a lot of control lines on it because it's got standby line and then a clockwise, anti-clockwise controller, which is it does eat up the I/O.
Which is why exactly. Which is why it needs the chip under the, underneath the.
It gives
you could actually get rid of that. Yeah, you can actually get rid of that and put them there.
No, not for the real encoders. You can't.
Yeah, gate it comes free because we use it for the encoders to get double the resolution out of them.
But you don't need to do that.
You say that now. Show us.
I did show you. I showed you right at the beginning. This one that I implemented with your code has the same resolution on the encoders with it running, doubling the thing, but it's all done in the misconception appears to be that the Arduino only has 2 interrupts, and it doesn't. It has interrupts on all the pins, and so it uses 4 separate pins with 4 separate interrupts. Yeah, it just groups them into groups of 8. So you can use 2 pins from 2 groups of 8 to do the same interrupt, and then all it has to do is check what they are. So because I thought it was the other way around.
I had a problem with the timer outputs then, because isn't it D8 and D9 which are commonly used as well for interrupts?
You can use any pin.
Motors on D2 to D5.
Yeah, but you can use any pin, so you can still use the 2 separate interrupts if you want to. It's just you can use 2 other ones. Any group will do, because you can mask the group so that only certain pins will react to it. So you can say, only these 2 pins will trigger the interrupt. So you can do it, and we have done it, and it's done on this one that's running the Maze Runner software. And there's very little difference between your interrupt routines and the interrupt routines on this. Few characters of code.
Well, David and some others are looking at a kind of revision too. So if you can communicate details with them.
Well, that was the point of this. Just consider it.
Doing away with the XOR would be terrific, because it's a pain completely. There's no question about that. And then there was driving the motors needed to be a phase enabled, because this motor driver, right, which we picked for availability. It's B6612FNG. which I had a horrible thing. But the problem is that the other motor drivers that are available were hard to find. Right? You couldn't just go. These were the most common motor drivers. To be fair, we didn't look at doing it by hand with the MOSFET gate drivers. So that would be, I mean, really, they're just a half bridge. Each one's just a half, 2 half bridges, isn't it?
Yeah.
So you can use them like a full bridge driver. So yeah.
But yeah, Derek, if you could send me that stuff about those, I'll have a look at that as part of our enhancement of the basic board sort of ideas that we're doing with Chris Bomford's helping me as well.
Okay, that's fine. I'll just send you.
Oh, that'd be great. Thanks.
What we've done with that.
David, a quick question then. If you're looking at next year running with UKMARSBot, I get practical stuff. We're down to one line follower board left. We have actually used up the last all but one of them now. So I guess I've got a question, which is, do we order more of the previous, of the earlier version that we've got now? Or do you want to hold fire and press on and try and get a new release, given that you're probably going to be starting in September?
Yeah, I mean, I think we should just order some more of the version 1. I mean, how much you're talking about? 20 or 30 quid for a runner boards?
It's less than that. It's about 20 US. I think it comes in about 14 quid or something for 20 hours.
I'm trying to get rid of this big pile of gold I'm sitting on. So it keeps getting bigger and it's not comfortable to sleep on at all.
Well, okay. Well, I'll spend it for it then.
Yeah.
But we're going to get some expenditure coming up, hopefully on the half-size stuff as well. But I think it'd be a good idea. I mean, Harm was the last, but I sent one out to Holland because Harm sent his photo around, so he's obviously started building his board up. But that lasers with just one line board at the moment. So I'll order another bunch, Rob.
Yeah, it's bound to be a little while before we get the new version going, I suspect. So,
and I don't want to be delaying. I don't want to be stalling people. I think if someone wants to join or wants to start building, we want to give them the stuff straight away.
How many maze solver boards and maze solver sensors and base boards have we got?
I'm running a lower on base boards, but David, you've got about 20, I think, haven't you?
I've still got about 20, yeah.
Right, okay.
I've got about 10.
The Birmingham ones.
Yeah, and I've got about at least a dozen, I think, maze sensor boards. It's the line sensor boards because we gave 15, I think, to Denham, John Fisher's school project this year. So that was pretty much our stock of line boards going on there. And a big dent, fortunately, a big dent in my BCU provided motherboards.
I have an alternative, I think I showed you, maze with twin front sensors. Unfortunately, I was going to send one off to Dave for testing, and I realised that I messed up, and they're no good. Well, they're much good. So I redo them. But once I've if we've still got 15 or so left, that's fine. Once I've redone them and verified the design, I suggest that we try and swap to that as the standard because the single front sensor is not really, in the end, it's not up to the job. It'll work, but it's not really up to the job.
No, I'm happy with that. If you say once we get that one working.
Okay. Okay, I'll sort out an order. I'll just place a repeat order on the PCB fab, and that'll be fine. I had one other thing which, unfortunately, some people will have to call now, which probably I need to get involved. I'll give you a heads up on it, which is I am going to propose a change to our wall follower rules. Our wall follower rules currently say that if you start a run before the maze time has run out, you're allowed to finish that run, which is different to how we time the maze competition. And I would rather have those two in line, and the timing gear certainly doesn't do that at the moment. The timing gear says, okay, your time's up. So
I would propose the opposite to that you allow the maze to finish its run if it started before it. Yeah, and I think that would be a good idea, especially if you've got a very slow mouse, because of our much tighter times that we have now. You might get someone that will start, and it's just, it's heartbreaking to have your mouse taken out when it's just about to go to the center. I personally, I would go for, if you've started, then you can finish.
That could take a while with some of the robots that run in our competitions.
Yeah.
Some of them will take a minute and a half to get there.
Yeah, that's fine.
It's not fun when you're trying to control the entry times.
Well, if you started, so you can finish or crash, right?
Yeah, or crash. Yes. Yeah, absolutely. You can't touch it once that last second has gone.
One of the I understand the motivation, and I'm not kind of averse to it, because you're right. If you start and then you run out of time, it's frustrating. Whether you should have even bothered to start knowing you couldn't finish is another question. But there was really a thing when we were trying to squeeze a lot of contests into the one day about simply getting through the schedule. And that's if things did drag, and some of the robots, they can be just so appalling slow that fixing the time limit is not necessarily a bad thing, I think.
You could always make it judge's discretion.
I have two views on this. One, as the maker of very slow robots, I quite like to see it finish. But also, as the person that's programming the RAT's timing system, I quite like the simplicity of saying, when your time's up, your time's up.
I agree they should definitely be the same, whatever it is.
We should allow people, if they've started, to finish, right? And we should let them find out what the time is. But if they don't finish within the allotted set time, they can't win a prize. But if it comes down to nobody finished in the allotted session time and they all ran over, well, then we can judge who might have won out of all of that, right? But anyway,
I'm not totally happy about just leaving it open to, if you started, you can finish, and having as we've had to run several competitions. You can get really squeezed on time, right? It just becomes a problem. So I think we need to think more carefully about that. So the beauty about the maze timing system is you're out of time, you're out of time. It's game over. And you can hold your schedule, because if you've allowed 5 minutes for an entry, they're not going to take more than 5 minutes, and you're not going to get a series of people taking more than 5 minutes.
I think the problem is as well, if somebody is started but they aren't actually trying to do a fast run, but they're still actually exploring, they could go on exploring for another 5 minutes, 10 minutes, an endless time going round in loop.
They would know that. I mean, and if they've been to the centre 5 times, then they can stop it. But we have had in the past some really slow ones that have literally about to go around the last corner, and it's the first time they've ever got to the centre of a maze, and the time has stopped. It's just, and we never saw them again. I wonder why. It's just it's the most annoying thing. I'm not bothered about my ones or anything. It's that sort of thing. But yeah, I mean, judges perhaps just if we've got time, that sort of thing. But I'm sure I've brought this up before, that the timer shouldn't stop even if the time's run out, so that we can at least see what the time was on the one that was, on the run that was missing. Yeah, if it's a fast one. If it's one of Pete's, you might want to see if he's done not 1/10 of a second off of it, even though it doesn't count.
Yeah, okay, but I just, it's we've got to come up with something that we can put in the rules, basically. And saying if it's a fast one, we'll let it happen, and if it's a slow one, we won't. Then we'd have to be as prescriptive about that. So, okay, I do think we have a lot of discussion on that, but we clearly have. So I'm going to come back to it if you can give it some thought. I'm kind of minded. You really want to do this stuff. I really don't want to change the bloody code. At the very least, I'd want to put some constraints on any overtime that people are allowed. I don't think their runs should count, but they could get a time. But even we should put a limit on how long you've got to get a time. If you're on the last corner, that's fine. But if you're, just started out,
okay,
and you're going to take over a minute,
a discussion like this is like when people bring stuff up in the pub, right? Everybody's suddenly got an idea off the top of their head, and perhaps it would be a good idea to go away and think about it. And then come back and talk about it some more.
I agree.
Yep.
I'm really glad they raised that now.
It's rules. Whenever you try and change the rules, there's going to be there's going to be all sorts to pay.
What's interesting is that a lot of people don't actually know what the rules are quite often when you cut to the chase. Okay. That was my tuppence worth. Next time we have got, I think I'm not sure whether John's coming or Simon Clapson's coming, but someone's going to give us a talk on the Lebanon School project that they're starting. John's been obviously fairly active with the board, and I think he's got PiPicos on it, hasn't he? And that's how he's trying to run it.
Was that? Sorry, what was? Who's when?
Our next session, which will be the beginning of September.
Okay.
He's going to update us on what they're doing with the school project that we gave them a whole bunch of boards for, and they've been putting Picos on and dot tip pens through the middle of a robot and all sorts of bits and pieces that we've seen.
Right. Okay. That's good. I thought you had me down for KiCad, but I'm more than happy.
No, I'm just a moment. No, I think you're the one after that, actually. Just a minute.
It's all right. It's not. The front page only does so many, so it's fine. That's fine. I just don't have to rush revising KiCad, so that's good.
So if you go to the events page, Peter, you'll see what day. I've actually put you in, but I think you're in October. Or November, actually, because we don't have one in October, right? You're in November after we do.
Plenty of procrastinating time now. That's good.
Well, exactly. There you go.
Wouldn't want to rush it.
You will anyway. Anybody else? Anything? Stop me by one? No.
Not anybody else. I've got a quick question for Pete. How many bearings on the half-size MicroMouse? How many bearings have you got on the wheel?
We don't have any particular number at the moment, but given that the current proposal is for 4-wheel mouse, there would be 2 per wheel and therefore 8 altogether.
Right. Yeah, no, I think per wheel is what I'm looking at, because obviously that,
2 per
how
wheel,
do you then attach the magnet to the end of that for the magnetic encoder? Or you're still looking at how that's done?
We haven't got to that, deciding that at the moment, right? But I can send you some pictures of what is in my head. I've been
looking at small MicroMouse, half-size mice, and I find an awful lot of them seem to somehow manage to get the wheel and then the magnet inside the sort of main thing with the thing right up against it, and then the battery in between, with something that's 3 centimeters wide. And
they are clever. I'll give them that.
There's some There's definitely something I'm missing going on there.
Well, what you may be missing is that they're not doing stuff how you might do it on a full-size mouse. So
yeah,
everything is almost certainly a press fit, right? And so you don't, for example, where on a full-size mouse, you might have a bearing block, the wheel mount, right? And you'd have a bearing inset here, and you'd have a bearing inset here, and then you'd have a shoulder between them, and then you're kind of pressing against that with a spacer. You're not getting any of that. You're just putting two bearings right next to each other, and the bearings are only at most 2 millimeters in thickness, maybe 2.5, right? And so there's 5 millimeters just like that. And the only thing that stops the whole thing from rocking out is the fact that it's a decent press fit.
Yeah. I know some of them pushed together. Yeah, there are some technical drawings of things, and some of them I've seen have got one bearing in the wheel. If you do that, the wheel just seems to wobble all over the place because the bearings aren't designed for that sort of load. Qtong Yong uses a great big bearing, and so that mitigates some of that problem. Okay. Let's see if I can find the picture. Not that. Talk amongst yourselves. So let me just share a thing here. A window. Oh, I don't know that that'll work because it's not a real window, it's a preview window. You do your screen. It should work. Yeah. Or entire screen. Make sure I haven't got any leftover X-rated material, obviously. Right. So that's XR Mini, right? And he's got a whole bunch of bearings, but what he's done there. Do you see my mouse move? Yeah. Yeah, okay. So what he's done here is these two bearings at the back are inside the wheel mount, but these two are inside the wheel. Right? And and so the motor shaft goes into the mount here. Yeah. But it's fixed to the wheel here. Yeah. Yeah, and that's because you don't need to put the motion through to the other side. And that's how you would do that's how we do a standard wheel, which is the bearings are inside the wheel and you've just got a bolt effectively on the other end. Yeah. So this one uses a great big bearing retained in the motor mount. I don't think that's a very good prospect. Okay. It's heavy. I've built something like that with a big bearing where the thing can go right through the middle, and it makes it very, very heavy. Those bearings weigh a ton. You see, even this one, he's just got pairs of bearings pushed in. Okay. So his motor mount is like 5 millimeters thick, and then there's a pair of bearings pushed into each hole. And you can see here, there's just a little piece of plastic tube pushed over the end of the shaft to retain the wheel. Yeah, but it's pushed into the magnet holder. Yeah. That can't be 5 millimeters thick. That. Well, maybe 4. I don't know. Yeah. But the question is he using 2? Because I know some people don't. There's a few technical drawings that show them just using 1 bearing, but I can't get that. I can't get that to work. He's got one on the front too. Or he's found a very wide bearing, which I guess is possible. You never know. They have access to stuff that we can't. Yeah, absolutely. Yeah. Okay. I just wondered what your thoughts were on it and what you were looking at doing, because obviously you want something that's really simple. But most of the ones I've come up with end up so wide that you end up with the boards with the sensors right in the middle and taking up 3/4 of the mouse, which which just doesn't seem to happen to any of the Japanese ones. They seem to squash it all into a really small area.
Zirconia. Matsui. Zirconia. Drivetrain. Right, so his drivetrain on Zirconia, he has he shows the bearings as quite narrow. I can't find the motor mount to measure it now, but I think the motor mount's about 5 millimeters. And you can just see in here the kind of shadow of two bearings. They're very tiny. Those are very small bearings. They're 1 millimeter ID bearings. They're tiny and quite small, which is much like tiny, really, when you get down to it.
Right, but even when you get down to very small bearings, you rarely get bearings that are less than 2 millimeters thick. You know, that's small. You can get them if you go right down.
Well,
so that's instantly 4 with a bit in the middle because you don't want them touching.
It doesn't matter if they touch.
No, I suppose
the
not.
inner races are rotating together, so
yeah,
that wouldn't matter. But it is all just press fit. There's nothing glued or fixed or retained in any other way.
I suppose the magnet will suck itself onto the little metal axle anyway.
Well, that sits in a cup. That sits in a small cup, and the cup pushes onto the end of the shaft and retains that.
So it's a bit like that then.
I don't know why I'm moving closer. It won't make it any better.
Can you see it? No. Oh, there we go. Let's go. There we go. I can see my picture now.
Yeah.
A bit like that.
Yeah, I guess.
Yeah. But in my view, that's too wide. It's just, you put 2 of those on and you've got something that's, 4 centimeters wide already without putting anything in the middle.
It's a shame.
It is. Okay.
And don't forget, there are people out there in Japan who've made them quarter size.
Yeah, no, absolutely.
I did wonder, by the way, if ball bearings are really necessary.
Yeah, that is a question, I suppose.
What are you suggesting, Pete?
Just a plain bearing, a very well-made hole, which may or may not be lined with a brass tube, and just a shaft going right through it.
We played around with PTFE tube you can insert into it. And that's okay, but it's more wobbly and there's definitely much more friction. So it really depends on...
What about a nylon mount?
Yeah, that's exactly PTFE nylon plastic. Yeah. So PTFE is extra slippery.
Yeah.
It's about as slippery as you get on it as a plastic.
It's a question of whether you have, power to spare, or people put in bearings because it's the right thing to do. But your car crankshaft runs in plain bearings, right?
Yeah.
Yeah. Just.
Yeah. I mean, they're very well made, but
don't use ball races, do they?
Sorry?
No. Plain bearings. Just oiled.
Yeah.
Lots of oil everywhere. Yeah, that's.
Room for some fun there.
There's that rule about not leaving stuff contaminating the maze as well. If it's a British made, you'll have to carry your own to clean up.
Yeah, they don't have to run for very long at a time, so I don't know. Anyway, that's all I was trying to see. That's what we were looking at, and I was trying to see whether there was any. There's a couple of other oddities that I saw. One that actually uses a magnet as the axle for the thing.
Yes,
the magnet goes through.
You can buy the regularly polarized magnets in something like 2 or 3 millimeter by 10 millimeter, and that's long enough to use the shaft. That's something I considered, and I've talked about that with other people. And then the consensus is that the trade-off might be that you end up needing ceramic bearings, which are horrifically hard to find.
Yeah, and to get hold, I did think that, and to get hold of those at that size is even more horrendous. Yeah, to get rid of them, to get them at all, they're expensive. To get them at that size.
With that said, they often put a metal disc, a metal sleeve around the bearing because of interference from the magnets in the motor or the magnetic field of the motor. So they're shielding it, then maybe the bearings, would act as a reasonable shield and still have enough field left over for the encoder. So, I've actually got some of the magnets somewhere. It would be worth trying.
Yeah, I mean, what is it about the bearing that has a problem with the magnet? Increased friction maybe because the balls are pulled towards the magnet, but I can't really imagine that.
It might close the field down so much that the encoder can't respond.
Right. So you won't get any eddy currents coming in because it's spinning round and next to something else and all this sort of nonsense that could give you a bit of resistance.
Who knows at that scale? I don't know. You need to do experiments, or you need to have a lot of people doing different experiments, and that's what they have in Japan that we don't have.
Yeah, there's loads and loads of people trying
lots of different things, and the stuff very quickly bubbles to the top, and we get to pick it off because we don't have the or the person hours needed to do that kind of research.
Yeah.
Okay.
Cool. Okay, well, I think I've got to shoot, guys. If you want to carry on talking, I'll leave the call open with pleasure. But
I need to as well.
Yeah, good to see everybody. Take care now.
Okay. See you next month.
Take care.
Bye. Bye. Pete, before you go.
All going to go now.
Pete.
Oh,
Pete.
Mouse. Yes.
Before you go, I still can't get the sensors to stream on my MarsBot.
How do you mean?
I think it's because it's not reading the value for when the switch is in position 1. Do you know what voltage you should get?
No. I mean,
I saw there was an Excel spreadsheet somewhere.
Yeah, but
does that give all the voltages?
I don't know exactly what they should be now off the top of my head, but the no, I'd have to work it out. But the code's got the ADC reading, so you can test the ADC reading. It might be that you've got an out of spec resistor or something else. I mean, the thing to do is just bang in a little bit of code that constantly tells you what the switch reading is, and then just flip them all and see what comes out.
Yeah, but I saw that, say, there was an Excel spreadsheet somewhere on that was referencing the dip switch resistor matrix or something. I wondered if the voltages were in there for the
I'm
different
not sure we ever put
combinations.
that up. Choosing motors, fitting encoders, assemble the main board. I'm not sure we ever actually put that up anywhere. Function selector. Where are we? No, it doesn't say. You'd have to look at what's in the code for the thresholds between the two, and it might be a bit close. I know they're closer than I would like, but it's the best we can do with still having the 4 switches and the push button all there as well. So I think what I would do in your case is to just have something which reports the ADC reading back to you over the serial constantly in a loop, and then fiddle with the switches and just see what numbers you get back and compare them. And if they are wildly out, let me know, because we might need to do some tweaking on the thing. And just double check your resistor values.
Yeah, I've done that, and they are all correct, because I thought, maybe I've got one wrong.
I don't know. And you're not. I know this is a stupid question, but you're not actually reading them backwards, are you? You're not reading switch 1 instead of switch 4.
No.
Okay.
Yeah,
Switch 1 is the out. Switch 1 is the outermost one, the one closest to the edge of the board.
Hmm?
Switch 1.
Yeah.
No, it's not. Switch 1 is the innermost one. See? Switch 1 is the innermost one. So if you're looking at the mouse from the back, it's a binary number, most significant bit on the left.
Right, okay.
Even though they're not numbered that way on the device, but that's how they're read.
Yeah. And the switch is on when it's pushed forward
Good question.
as well.
Yes, I think they should be. Right? So it's up is 1, down is 0, and they are read left to right when viewed from the rear. Right? But that's not how they're numbered, because the part is just a crazy part.
Right, okay.
Yes, it is.
So it's the innermost switch is switch 1.
It's bit 0. Yeah.
Yeah.
It's the least significant bit is on the right.
Okay, I'll look at that again. And you reckon in the code it's got the upper and lower values for the ADC values?
Yeah. There's just a table there, and they are the halfway between thresholds, and so it just runs through the table until it finds a value bigger or smaller and decides that's where it must be. It's pretty brutal.
Right, okay, I'll give that a go.
All right.
Okay, cheers.
Okay. Gotta go then.
Bye.
Cheers, guys.
Yes. Bye.
Bye.